Let's start with the second lecture with more. Sorry. Yeah. Let's start with the second lecture in the series of History of Science about the scientific revolution. But not before I get back to you about the assignment that you had in for last week. A short interlude about the syllabus, and then you get to the point of the scientific revolution that you'll be making another assignment about. This is a strange course in many ways. First of all, we are migrating across campus, as you might have noticed. Today and next week, we'll be sitting in this room, enjoying the views of the adjacent room where beer is being served. Next, in 2 weeks, we'll be in the main building and then in some other place again. That's okay. Migrating will not hurt us. It might just hamper attendance now and then. But it's a strange course in that what is expected of you as well. I am aware of that. And last week, you were my guinea pigs, and I tried something completely new, trying out whether that would improve results in assignments, and I found out that it didn't. So I did for today reserve quite some time to discuss the assignments. Don't be alarmed. The important thing about the assignments, in my opinion, is the feedback. So please do read the feedback. The grades completely irrelevant for now. In the end, if you're not scoring 6 or more in average, in the end there will be a possibility to hand in 2 assignments again and improve your grade above the level of 6. So the grade is not important. See it as an opportunity to get to grips with what I think you should be learning here, which is about, stories. Amazing stories. In general, mention details, not because you want to, also because you want to show off that you know a lot, but try to have them, try to come up with sensible details. That's details that help illustrate your case. In a couple of the feedback that I did read from Vincent, it said, at least mention this or that. What he intended to say, or what we intend to say, is, for example, mention that. In some cases, it's quite appropriate to mention other details. It doesn't matter which details should help build your case, but they also help set the scene. So in that sense, details might always help. And details like, oh, I know this guy, or I know this book, describe a little, at least help you to impress me when I'm correcting your example. Yeah. So I'm easily impressed. So mention details. Make it story. Second point. Try to bring in a sensible structure in your text. What I do, and I'll show you a couple. I'll show you 2 examples of the way that I work in the reflection exercises. I start simply with structure. These are the 3 points I want to make, and on the slides I won't go into details about what the story of all these points is going to be. I'll do that orally here, but on paper you can work the same way. You can start by making your 3 points and then write the story around these points, each section building on that particular point, providing the details that belong to that point, or something like that. And avoid judicial language. Should you avoid it always? No, definitely not. Try to bring in judicial language in ordinary life as much as you can. But what I want you to teach, what I want to bring over here, what I want to get across, is that we do use judicial language quite a lot for a purpose, either political or just voicing our opinion because we like it so much. But there is a reason, and there's nothing wrong with voicing an opinion. But be aware that mostly it is an opinion, and So one of the most common things that I came across was the something or someone being ahead of its time. Yeah, that's a very clear, perhaps you're not aware of that, but that's a very clear judgment. It presupposes that what we have become, what we think that, for example, mathematics is about, or what we think that the world is going to right now, that's the perfect and the ultimate, and that's the only way that history could have ended. Well, it's the way that history did go, but people could have made other choices in the past, and some of them tried to. They simply didn't succeed. So, saying that, yeah, he was ahead of his time, is just out of question here. People do say it a lot. I read a text, just the other day, I read a text about Dedekind, where it states that he was ahead of his time in mathematics. And in a sense he is. I agree. But it is a prejudice because, at the time, it was not clear that that was going to be the way that mathematics should be. There's a lot of horrible. Okay, so if someone uses a phrase like this, it usually has a political meaning. They want to achieve something. They want to emphasize that this is how we do it, and that's the way we should do it, and you can't do it any other way. And he may be right, or at least he may agree. Usually I do agree. I agree on Dedekind, but that's not the point. By saying that he is ahead of his time, you kind of, at least in this class, you kind of make it impossible for other people to disagree with you, because of course it should have been that way. And you can disagree. At least here you can. In politics it's sometimes not smart to disagree on certain occasions, and but here we can. And please feel free to disagree. Okay, now some specifics. One of the things I came across was the prejudice that everything with number in it is mathematics. And one of the things I did try to get across, and I evidently didn't get across too well last week, was that isn't the case. Not everything with numbers in it is mathematics. In the Bible, in the Gilgamesh epos predating the Bible by another 1,000 years, the oldest part of the Bible, there's a lot of use of number in a religious sense, in a mythical sense. Mystical perhaps even, but certainly mythical. The Gilgamesh epos is about King Gilgamesh, and King Gilgamesh is measured continually. Yes? His strides were 7 ells wide, and his chest was, things like that. Continually coming up with numbers, with statistics, you could say, but it isn't really. It's serving the purpose here of making the king stand tall, and great to the background of his simple folk. He had this great city that he ruled, and the numbers come up with so many 100 ells of wall and so many 100 soldiers, and etc., etc. Numbers are in the Bible and in many of the old texts, and even in the temples, used for mythical or mystical purposes. Even when they're used for simple bookkeeping exercises. So a better example you can read about in the syllabus is on probability. Probability theory was a part of law, not a part of philosophy, and thereby not a part of mathematics. Probability theory in games of chance or whatever kind of probability decided how things should be divided, who was winning and who was not. It was either the lawyer, or the king, or God who could decide upon fate. And numbers, probabilities, were not there yet. Were not there, no. I wouldn't even try. I wouldn't even dare using the word yet here. They were not considered, they were not conceived as probabilities. We would say, yeah, a probability, they would think of, yeah, well, God is going to decide here, he just hasn't yet. Well, let me do it in his place. Yeah? And the king could, and the lawyer could. And he was the one who decided upon, yeah, Leibniz, for example. I hope you have heard of the name, and if you haven't, think of him as one of these great mathematicians of the 17th and 18th centuries. Yeah? Really brilliant mathematician. He studied law. And yes, he did quite a lot of mathematics. Quite a lot. An impressive lot even. But he also practiced law. And as a lawyer, he wrote about probability theory. Today, we might look at his probability book and say, he's making mathematical errors. And yes, he is. But as a lawyer, that made perfect sense in his conception of probability. He was not doing our probability theory. That's the whole point. So being occupied with numbers does not make you a mathematician. It's even worse. Numbers are not necessarily a mathematical object. And they only became so in, well, the early Middle Ages, I would say. Perhaps with the Romans. Yeah, that's a matter of speaking, of course. And you can contradict, you can disagree. It depends on what you think is important here. So not everything with number is mathematics. Another one that I came across, mathematics today is at the basis of all other sciences. I like to think so, I really do. I really do. But is it now? Looking back, I hope, I inquired during the time that you came in, and many of you have not been able to read up with the chapters in the syllabus, which is a pity because it really helps you get some sense of what I'm talking about. So please try to read up. But yeah, mathematics is the basis of all other sciences. In the early Middle Ages, mathematics wasn't at the basis of all other sciences. It was one of the simplest examples of philosophy. Yeah, and it could help in doing theology and in doing law and in doing medicine, but it wasn't there for its own sake. It certainly was not the basis of all science. It would have been a preposterous remark. So today, that's of course the important word here, today. Is it today? Well, I do like to think so. But do go across the other side. Ask the chemist. Ask the, well, even worse, the physician, the doctor, the medicine doctor. Does he think that mathematics is at the basis of his profession? Well, mathematics is one of the courses he had to take, and he didn't particularly like it, mostly. Yeah? So, yeah, in a sense, in some Platonic sense, we like to think that mathematics is at the basis of all sciences. And I really do want to believe that with you, but in practice, it might turn out that mathematics becomes completely and utterly obsolete. Yeah, at least the mathematics that we now study. And of course, we won't let that happen, but we won't not let that happen by thinking that mathematics is at the basis of everything. No, it takes an effort, and it takes taking the other opinion of the chemist and of the medicine man serious to understand why he thinks that is not the case. It takes an effort. Okay. So what's in a name? In many of the Anglican countries, in the United Kingdom and the United States, there is no course in mathematics at secondary school. There's the course science. Yeah. And mathematics is an integral part of all the science courses. It's not mentioned as a separate science. With the coming of science, and it's even been suggested that we introduce the science courses here in the Netherlands because of a shortage of mathematics teachers. With the introduction of a science course in secondary school, mathematics would disappear, would become invisible to the ordinary people as the basis of all other sciences, definitely. It's kind of a horror scenario in my view, but this might happen, yeah? Okay, there are other prejudices. I give you a few quotes from your work, and I hope you'll help me out by spotting the prejudice here. Let's start with the first one. This gave Alfonso the opportunity to gather a court of Muslims, Jews, and Christians together. This intermingling of cultures and faith had the primary purpose to translate Hebrew and Arabic books into Latin. Where is the prejudice here? Where is it hiding? Someone, please. Or is this too? Yeah?
Maybe that back then the cultures were not that divided, but nowadays you see Jews and Christians as completely different cultures.
That could be, that's not the case, but this is, I like that, yeah? Yeah, but you're thinking broadly here, good, but it is about cultures. You see not one?
Yeah, I'm not sure, but I thought about the languages maybe, that they relate Latin to Christians.
Yeah, that's correct. That's correct, actually.
Because I know there are Christians that speak Arabic, for example.
Yeah, but yeah, a couple of them did. That's true. So there's a little prejudice there as well. The big one here is in the intermingling, I would say. Intermingling in the 13th century, certainly with respect to Jews, but also with respect to Muslims at the time, meant bashing their heads in. Yeah, there was no idea of intermingling faith and religion, not in the 13th century. That's a common idea of today, yes. But at that time, intermingling was, well, if you intermingled, then you were sure to have a big knife with you to yeah. Jews, that were the people who had killed Jesus, right? So you don't want them in your city, not too much. Suddenly if they become rich and successful, and you want them out. In most European cities, Jews were not allowed to possess land or a house, for example. Not by life. So what most of them did was spend their money on their grave. And that's why in older cities you still may find huge and beautifully equipped Jewish graveyards.
Also gold and stuff, right? Like
yeah, quite. But no possessions of land or houses in the city, that was forbidden to them. So intermingling, yes, but not in our sense of the word. That's the prejudice here, or that's at least one of the prejudices. I like the one you mentioned as well. Yeah, languages. It was not uncommon. If you were a learned Christian in the 13th century, you definitely knew your Arabic. that was the place where you could find knowledge, not in Latin, not yet. Okay, the second one. With this process, and the process described here as doing mathematical exercises, our analytic thinking level is developed and increased, which is an essential mental tool. What is the prejudice here?
That it's essential.
That it's essential? That's definitely a prejudice, yeah. Why would it be essential? Why would it be essential? Is it essential according to you?
Well, you can't just state that it's essential, right? Because what's essential and what's not depends on
Quite. Yeah, and we may think it's essential, at least I like to think it's essential, but that doesn't make it essential by definition, right? It makes it essential by my definition. Yeah, that's about the same problem that I described last week. What is mathematics? Yeah, but mathematics is what a mathematician does. Oh, just he's doing mathematics. So you always end up in a circle here. And there's nothing you need the prejudice, you need to prejudice to function. But be aware of the fact that you do use it. That's the point. There are two here actually, so you could say essential, but there's another one hidden here, which I like to debunk for you. Anyone? Yeah?
How are you so sure that our analytic thinking level has developed?
Quite. Why would our analytical thinking level develop by doing mathematics exercises? Why? I like to think so. Again, I really like to think so. But yeah, how do we get to that idea? Yeah.
But if you give a proof that it increases,
Yeah.
like a study or something, then it isn't prejudice, right?
But how would you go about proving this? I have an idea.
You can give maybe a study.
Yeah, but if you go test
How
it,
would you test analytic thinking?
how would you? You could try to test it by saying, "Oh well, let's see whether they can solve this exercise then." But by defining the exercise, you end up in the same circle that you start with. Yeah, definitely. You can define intelligence by saying you're able to do mathematics, and then that by definition you should know mathematics to be called intelligent, and it works. Still, you may have that prejudice. There's nothing wrong with the prejudice itself. I thoroughly believe that every intelligent man or woman is capable of doing mathematics. I thoroughly do. Although I've come across quite a few who didn't, but and who I did consider intelligent. Yeah, I think they just missed an opportunity there. But that's, yeah, I'm aware of the fact that I'm stretching my own definition there, yeah? Fully aware of that. You can still have that prejudice. There's nothing wrong, please don't let anyone fool you, there's nothing wrong. You need a prejudice to function. So, but here is one. The third one. Technology is a huge part of our day-to-day lives. To understand it better, it is essential to be educated in the fundamentals of math. For this reason, mathematics can be considered as useful for every human being. Yeah, it's useful for every human because it's better to understand the fundamentals. Yeah, where's the prejudice here? Yeah, please.
Technology is a huge part of our day-to-day lives, but not everyone's. Why would it be
What?
for every human being?
That's certainly one good point. Yeah, technology is not.
It is essential to be educated in the fundamentals of math.
Yeah. Why? Why essential? Yeah. Why not the fundamentals of technology? Yeah. Why not? Yeah. And what does it mean?
Physics that we use to build it.
Yeah. Yeah. So these kind of phrases are very, very good to use as one of the views that you use, that you can use in the B questions, in the reflection questions, yes? And then you go about and try to figure out what's the value that's there, that's hidden there. What does this person feel that's important in life or in mathematics or in technology or in whatever your point is that you're trying to make. Try to get beneath the surface, try to spot the prejudice, weigh it for what it's worth, take it serious, because it's not, people may think this, and it's not complete knowledge. There's some point to it, but yeah.
Would you argue that the fact that you only need maths to understand technology is a prejudice? Would you argue that you need more than that, or is that not?
Or perhaps no math.
Yeah.
It depends on what you call math, really. So, I'm acquainted to a carpenter, very well, he's brilliant with his hands. He can, we built this attic together, and I'm a mathematician by training, so I like to think that I know what I do when I measure the beams and the plates that go up to an attic, and construct that, so set out the right angles and yeah, measuring this, measuring that, and measuring 10 times before I dare to put in a saw and actually cut off a beam and make it short or whatever, yeah? And he does it by just not looking at me. He just starts. He takes out his tools, does the trick, and it fits better than me with all my measuring and thinking. And of course you can say that I'm simply clumsy, and I am, but yeah, but he has no mathematical training at all.
So
Experience is worth something. At least in this profession it is. Yeah. Is it always? Well, no, definitely not. I like to think that my mathematics counts for something. Yeah. Yeah. But I do value his work way over my carpentry anyway. Yeah. That's okay. Here's some more. This is about Alfonso, you can guess. Only centuries later would that sarcastic title lose its sting and become one of praise. It's quite melancholic. I like that phrase. I like that phrase very much. It's quite melancholic that Alfonso would never get to hear the praise he was due as a man ahead of his time. Yeah, here is the ahead of his time definite. I already pointed it out to you. I just want to show you. It's a beautiful phrase. Let's be honest. This is beautifully phrased. But be careful. If you answer this on an A question, you kind of show to me that you've not grasped the intention quite yet. You're not freed of you're not aware of your prejudices. It's easily repaired. You can say many people would argue that he was ahead. Many people today would argue that he was ahead of his time. And that way, you save the day. And the second one, Euclid's Elements is one of the most important books ever written, as it contains the basis of what will become modern science. A modeling language of science, a modeling language of space, based on an axiomatic method. The one thing missing in Euclidean geometry to become modern mathematics is a good numerical system. Where's the prejudice here? Yeah?
I think one of them is the most important book, and the second one, a good numerical system. It's kind of biased on our society.
Yeah, yeah. Most important book. Yeah, most important book. Although I would agree, I definitely would agree with most important book, but is a prejudice here. What about the modeling language of space? Is that a prejudice? It did become the modeling language of space, right? Was that Euclid? I'd like to think differently, but you can state that geometry, not Euclid's geometry, but geometry in general, became the modeling language of space. So that's a bit of a fishy one. But the other one, a good numerical system, yeah. He didn't need a good numerical, even stronger. Euclid didn't want to use numbers. And there was a good numerical system at hand, mind you, yeah. Perhaps you don't know, perhaps you do know, but the Babylonians had a sexagesimal system that worked quite well. You could calculate with a place value system in the Babylonian, and the Greek knew that. They preferred their own ways of reckoning, but the system was there. But Euclid chose not to trust number. So there was a reason behind that. So saying that it is missing to become modern, yeah, that's kind of straight. It's kind of dismissing Euclid for thinking that, where he had a good sense for thinking that. Okay, remarkable that this one I find remarkable. It's not because there's much prejudice here, but I did find it remarkable. Industrialization and advancement this world has seen in the last 60 years could not have been achieved without the practical application of mathematics. Well, there is some judicial argument there, but had some prejudice here, but never mind. I like the second part mostly. However, as a result of this advancement, lifestyles which were completely unconnected with mathematics were also glorified. And this is a nice observation. It comes with an example here. Due to telecommunication advancements, actors and athletes have become world renowned. And now people want to become an athlete or a musician rather than a mathematician. So you see, this is the peculiar side effect that progress may have. And that's why I like it that much. Yeah, things happen. Things happen. And mostly they don't happen the way you want them. Things are the way they are, and rarely ever the way you would like them to be. So this is although in the first line there is some prejudice, the second and the third line make it up quite well. Good argument, with a nice example. Now, reflection. Just to get the notice all in the same direction. I want you to write a story, definitely a story, not just a few lines. If you just write a few lines, then you're not reflecting. Yeah, I want detail. I want detail in the A questions, but I also definitely want detail in the B questions. And then next week, the B questions won't start with reflect on. I expect you to remember that B is about reflecting. Yeah. So try to be specific. If your opinion applies to one specific name or a group of people, name them. If it applies to a certain period of time, name that period of time. Name that country. Be specific. Give an example, if you can. And if you can't, well, try to come up with one. Explain the example in some detail. There is a reflection document on Canvas with a suggested structure, level 0, level 1, level 2 is was not asked this week. I don't think I asked it this week, but never mind. Use that structure if you find this hard. But in general, try to come up with these prejudices. Try to see these prejudices, describe them in detail, describe some of the other prejudices that exist. There are many. You don't have to juxtapose the two extremes. There are many prejudices. We'll come across a few right now. Euclid's elements. The question here was reflect on the modernity of geometry in Euclid's elements. And you can pick out the word modern here and try to confront it with the ancient ways of doing geometry. And then you should come up with examples of definitions in which they differ in the ancient Greek elements. The definitions are hand waving. A point which is that which has no the point is that which has no length, breadth, or depth, something like that. Yeah. Do we know what the point is? Now, in present day mathematics, a definition should be something that you can use in proof. You can't use a definition like that, like Euclid gives, in a proof. So you can juxtapose these two ideas of definition. In the axioms, on your hand, it's more subtle. The axioms that Euclid provides are very recognizable as present-day axioms. They look modern, yet present-day axioms, if we do geometry nowadays, present-day axioms are, well, perhaps not chosen completely at random, but we are free to change one. For Euclid, he was describing reality. He was describing the world. So his axioms are the things that we find obvious, and that he finds it necessary to name the obvious. That's peculiar. That's wonderful. That makes him indeed close to us. But the reason for naming them axioms is slightly different from ours. So it's more subtle. the theorems or the proofs. I'll come with an example later. But if you want to juxtapose modern day, present day mathematical geometry with Euclidean geometry, you could take one of these four juxtapositions to illustrate your case, and you just need one. Say, this is what this is what you did for, this is what we think today, and then you can go on and try to face the prejudices and the values behind them. Values being always positive, not being negative. Okay. Another way of going about is doing it, juxtaposing the contemporary versus the historical way of looking at Euclid's elements. So taking it just a step back from the actual book and saying, yeah, the reasons for doing geometry with Euclid are completely different from the reasons of doing geometry today. The purpose of doing geometry is different. Yeah, that kind of stuff. You can juxtapose those two. You need other examples then. Yeah, then you have to explain about the mythical origins of Euclidean elements. And indeed, the description of generalized space today, where space can be a space of matrices or whatever you want, polynomials. So these are two ways of going about, starting off. Here's an example. I juxtapose modern, two types of modern. I pick out the word modern and think, well, modern can mean anything, right? Let's take two examples of modern thinking about mathematics and juxtapose these two. I take modern in the sense that it uses theorems and proofs in a logical, deductive fashion. That's the pure mathematical essence of mathematics. Well, hear me. But yeah, you could state that. And I juxtapose it with modern in the sense that, or not modern, and Euclid is not modern in the sense that it doesn't attempt to create algorithms. These are two, yeah? Because creating algorithms is one way, a very modern way of looking at mathematics. If you can't calculate it, then why do it theorem, right? So, your typical example would be book 7, theorems 1 and 2. Why these examples? Now it would have helped if you had read the syllabus. It's explained there in some detail that book 7, theorems 1 and 2 are about finding the greatest common divisor between two line segments. Yeah, because Euclid isn't talking about number, he's talking about line segments. Or more general even, he's talking about quantity, but not in the numerical sense of the word. Very strange phrase that he uses there. So the line segments could also be areas or volumes or angles or whatever, but they should have a certain ratio to one another, or they could have a certain ratio. And, well, theorems 1 and 2 in book 7 give you a way of calculating the greatest common divisor between two of these quantities. The present day mathematician would say this is thoroughly modern. He proves what he is about to say, and this is exactly what we think about as we speak of the greatest common divisor. That's what you could say. He values, here comes of course the core value, he values proof and the understanding that the proof brings. The essence of mathematics to him is in the proof. And in the fact that Euclid uses two theorems instead of one, which is easily done nowadays, is a detail of minor importance to him. The algorithmic thinker, however, will kind of oppose to that view. He will think, well, wait a minute, there's no algorithm here yet. Well, yeah, we can construct it from there. I think we can, yeah, we can. But why two algorithms? Why two theorems? And he will dive in and find, oh, there's one theorem where the two numbers are co-prime, and then there's one theorem where the two numbers are not co-prime. So the greatest common divisor is 1, or the greatest common divisor is not 1. Why? realizes, oh wait, Euclid is, he is not counting. He doesn't have, he needs unity here, but he doesn't believe in numbers. So the unity starting of any counting system is a difficult and ungraspable object. He treats it separately because it's very specific. We know what we mean by one. If we are counting, yes, we do. But that's too mundane for Euclid. Until the late 18th century, in many textbooks, 1 is not considered a number. 2 is. 2 is the smallest number, and then 3. And you still find that reflected in our definition of a prime number. Well, it's convenient, by the way, of course, you don't want 1 to be a prime number then. But, yeah. So, values are hidden within these two views, and you can juxtapose them. So, use the fact that a word like modern, and the other words that we use in common language, have more meanings, have multiple meanings, can mean different things to different people. Quickly about mathematics education, why is it useful and to whom? Well, mathematics education is useful because it teaches critical thinking, is one of the obvious prejudices that are used. And that's one of the views that you can use, of course. Try to pinpoint it to someone or to a group of people. If you have no particular name in mind, you could at least say many mathematics teachers think that is true, yeah? Something like that. Or my mathematics teacher here in class thinks that's true. But here, you can focus on 2 things. Why useful, the word useful, you can try to juxtapose different ideas about usefulness, and to whom. And this can be exploited in your answer in several ways. You can even combine them. The best reflection answers, of course, juxtapose more than just these 2 views. But 2 at least are required. Last week I gave you the example of 19th century Euclidean geometry, the textbook with all the colorful pictures in it, where the essence of geometry, Euclidean geometry, was in the complete system of thinking, the completeness of the whole mathematical treatment of space. And they tried to make it more insightful by presenting it in the form of pictures. So that was the most, and the late 20th century view of geometry, of Euclidean geometry, where the thinking was much more local, where it was not about an axiomatic system that was deduced, but where you could take a starting point, make a few reasoning steps, and end up somewhere else. That's the way people are taught geometry today in secondary school. At least the happy few who drew that kind of geometry. So it's more local, proving, reducing than the entire system. So there's a difference there. Give the examples and talk about the values in some detail. And values in education are often values in this question are often hidden in the ideas about education, or deeper in ideas about society, egalitarian or not egalitarian, or more superficial in ideas about mathematics. Well, you can pick your truth, you can pick your description here. I don't mind which one you pick, I do want you to reflect on it. That's what I hope to achieve. For now, very short, too short, I must confess, but please do ask me by mail or by discussion board or any other way here in class. Any questions about the text that you, even if you have just read the first 2 pages, any questions? If you come across, put them on the discussion board, or ask them here in class. I'll make some room in every lecture for questions. it's a book to become. It's not ready yet, as you may have spotted. I'm still writing the last chapters, which is, I hope, will be finished before the end of the course. But yeah, the idea is that it will be a book in a couple of years. You're the guinea pigs for testing the first version. There are probably some typos, so now and then I remove a few and add a few others. There's probably some problem with structure here and there, but not much anymore, not that much that I don't dare to have you read it. In general, during the first sections, during the first paragraphs of every chapter, there's an introduction to that chapter, why these subjects, and then the subjects are treated one by one. Any questions, please do come. Let's have a break and then continue with the scientific revolution. Thank you.